In grade 10, we solved trigonometric equations like, say, sine x. Okay, let me say maybe plus 2 is equal to. Okay, let me make this. Maybe I can make this 2,25. Right? So when you solve this, you use the calculator, obviously. So let me check out my calculator. Yeah, I'll answer that question later. All right. So here, if you want to solve a trigonometric equation like this, in grade 10, you were only solving when x was in the first quadrant, right? The reason why you only concentrated on the first quadrant was because you were still new to trigonometry, okay? Going forward, you need to know that when you solve any trigonometric equation, it has got many solutions. It has got an infinite number of solutions, okay? But in grade 10, it was only restricted to 0 to 90 degrees. So this will become sine x is equal to 0,25. Okay, you take the 2 to the right, then you get that. Then you say x is equal to shift sine of 0,25. Then if you take out the calculator, you press shift, then sine of 0,0. I never said should open WhatsApp. Okay, so this will be 0,25. Okay, so that will give you 14,48 degrees. Okay, so x will be equal to 14,48 degrees. Now, if you look at it here, at grade 10 level, your x value is acute, it's between 0 and 90. That's how far you went, right? Going forward in this grade, you need to know that any trigonometric equation has got more than one solution. It has got an infinite number of solutions. At this stage, I'm sure you can tell me that, Mr. Tona, if I subtract this angle from 180, I'll get a corresponding angle which gives me the same ratio. Right? Remember, sine is positive in the first and the what? And the second quadrant. So if we subtract this acute angle from 180, right, we will get an angle such that if we substitute it here where there is x, we'll get the same answer on the right hand side. Also, if we add 360 to this angle, we'll get a third angle, which if we substitute here, it will also give us another value which is the same as the one on the right. If you continue adding 360, right, and so on, you'll find that you get many solutions. It's just that last year you were only restricted to the first quadrant. Yes.
So could you say that the reason that it has an infinite amount of answers is because if you were to graph it, the intercept has an infinite amount of intercepts with the sine graph?
Yes, because the sine graph
having no restrictions.
Yes, the sine graph in mathematics we call it. There is a proper term. It's periodic. Okay, if you draw the graph of sine, it's periodic. So minus infinity to positive infinity. Right? There is a strong relationship between trigonometric equation and trigonometric graphs. There is a strong relationship. Okay? To understand trigonometric graphs, you need knowledge of trigonometric equations. So if you carry on adding 360 to the acute angle and the obtuse, you get an infinite number of solutions. Right? Now in grade 11, you've introduced to what's called the general solution, which is what I'm going to talk about just now. Right? So this is what you did last year. Okay, it was very basic. Okay, so the grade 12 one, sorry, the grade 11 one. So with grade 11 trig now, we'll start with what's called the general solution. I'll introduce the general solution. First, you need to know what is the general solution. Now, over the years, most learners, they just memorize the general solution without understanding what they are. The general solution is actually a group of formulae. Okay, it's a group of formulae. There are 5 of them. Okay, so the general solution is a formulae, or what I would say, a formulae. Okay, let me make it more plural. Formulae. And if I put solution, right? Formulae. Okay, we're talking about all of them. Formulae that are used to determine a formula, that can be used to find, that are used to determine a formula that can be used to find all the possible solutions, of trigonometric equations. Okay, let me make it similar. Okay, so the general solution or general solutions, they are a group of formulae, okay, that are used to determine a formula that can be used to find all the possible solutions of that equation, of that trigonometric equation. Okay, please be aware that they are general solutions. They are not the exact solutions. Okay, that's why I use the word formula. All right? Now, what are those formulas? Right, let's start with number 1. If sine theta is equal to A, right? Please be aware that whenever you solve a trigonometric equation, you get to a point where if the trigonometric equation is in terms of sine, you get sine theta equal to a ratio. Okay? You get like here. I hope you saw this. You see what I did here? I started with sine x plus 2, then I simplified until I got sine x equal to 0.25. So the A is like this 0.25. The sine theta is like this sine x. Right? So, if you've got a trigonometric equation where you reach this point here, you need to know that the value of theta can be in the first quadrant, because sine is positive in the first quadrant. It can also be in the second quadrant, because sine is positive in the second quadrant. So what this means is we can write this as theta would equal to shift sine of A. Right? Already you heard me saying the graph of, he also said it as well shown, that the graph of trigonometric functions are periodic. Therefore, we have got an infinite number of solutions. To get those solutions, we add k, which is an integer, times 360 degrees. Well, the 360 degrees refers to one revolution. So if k is an integer, it will depend on how many revolutions you have got. but the k must be a positive or a negative integer. So k must be an integer. Don't worry, I will explain into that part. But I've already explained it if you're paying attention. Where I said if we add, if we add 360 to this, right? We get 374,48. 374,48 will also be a valid solution to this equation. If I add minus 360 as well, here, to this one here, right? Okay, if I add minus 360, I won't get a solution because this is positive. But if I subtract this from 180, I'll get a value in the second part. That value, if I add 360 to it, it will be a valid solution. That's where this k comes in. That's k times 360 there. So for the equation which we have there, our k will be a positive 1. It can be a positive 2, but it can't be negative, right? So this k here, it refers to the number of times you add the 360. Okay, that's how I'm just simplifying. But the k can be negative as well. Okay? So this is the first general solution for sine. Okay, so I'm going to call it number 1, or I'll call it A rather. Okay, or, okay, by the way, we call this angle here, that angle, it's called the reference angle. Okay, it's an angle. Shift sign of A is an angle. Okay? Now, if we find this reference angle in the first quadrant, since we are dealing with an equation in terms of sine, it has got a sister or a brother in the second quadrant. So the angle in the second quadrant can be determined by subtracting this one here from 180 degrees. Okay? So the second general solution for sine will be theta is equal to 180 degrees minus shift sine of A plus k times 360 degrees, where k is an integer. Okay? Okay, by now, you should know that if I give you, okay, let me write it here. If I give you sine 20 degrees, this is equivalent to sine 160. If I give you sine 30 degrees, this is equivalent to sine 150. Okay? You should know that by now. Because of that, it means that whenever you have got a trigonometric equation in terms of sine, if you determine the acute angle, you need to be aware that there is also an obtuse angle which gives you the same solution to that trigonometric equation. That's why we have got two general solutions. So going forward, if you are solving an equation in terms of sine, you have to determine all the possible solutions using these two formulae. And these two formulae here are what are called the general solution. Okay? Because we can use them to determine all the possible solutions of the trigonometric equation. All right? So that's the first set. The second set is for cosine. So if you get to cosine of theta equal to A, it therefore means that your theta, now because cos is positive in the first quadrant and the fourth quadrant, right? So this will be plus or minus shift cos of A plus k times 360 degrees, where k is an integer, right? Please be aware of this. I hope, I just hope, if I give you, okay, again, this is our reference angle, by the way. This is going to be the reference angle. Okay, and generally the reference angle we consider the positive, right? For cos, if I give you cos 20 degrees, by now you should know that this is equivalent to. Now, if I give you cos, this is equivalent to cos minus 20 degrees. Okay? You should know that by now. Okay? So if you find your reference angle here, okay, as a positive, because of this plus or minus, you are going to end up having two angles. One will be positive, other one will be what? Negative. If you substitute both of them into the trigonometric equation, you get the same answer on the right hand side. Okay? You get the same answer on the right hand side. Are you following there? So we have got two general solutions for cos. Now, I can break this up, but there's no need, so I prefer to write as plus or minus. The plus or minus indicates that you have two values that are the same in terms of value, right? Or I would say in terms of magnitude, they are the same, but they differ now in terms of their size. Their magnitude is the same, but they differ in terms of their size. So there are two solutions. Okay, or rather there are two formulae. We can break this up and write the first one as shift cosine of A plus K times 360, right? Or we can write the other one as minus shift cos, right? It's also important for you to be aware that because the basic graphs, you see, the basic graphs of sine and cos, they've got periods that are equal to what? 360 degrees from your grade 10. Okay, that's also one of the reasons why we have to put that k times 360. So if you start, when k is 1, you're adding 360, right? Then if k is 2, you're adding another 360. If k is 3, another 360, then it carries on up to infinity. Okay? Then the last one, for tan, it's only one formula or one general solution. Okay? So if tan is, okay, tan theta is equal to A, because tan is positive in the first quadrant and the third quadrant. If you have an angle in the third quadrant, in the first quadrant, if you want to get the one in the third, you just add 180 to get the one in the third. I hope by now you know.
And tan graph only has one
Right?
arm.
And the period of a basic tan graph is 180 degrees. So this will be equal to shift tan of A plus K times 180. Please be very careful with this one, because you can put K times 360 by mistake there. Okay? Be very careful here. Okay? This is the reference angle. Okay? So, just to summarize this for time, be aware that if you get an angle here in the first quadrant, if you want to get its sister or brother, you just add 180 degrees and you come to the what? You come to the third quadrant. Okay? Also on the graph of a basic tan graph, I'm talking about basic tan graph which you learned last year, right? The period of a basic tan graph, it's 180 degrees. So after every 180 degrees, the tan graph starts to repeat itself. Okay? So, always multiply the k by 180 goes over. Right? So we've got 5 general solutions. 2 for sine, 2 for cos, 1 for tan. Alright? Okay. I'm going to stop.